do one more question. This question, if the manometer readings are 800 millimetres and 200 millimetres, what is the flow? And it does tell you the density of the flowing water is 1,000 kilograms per metre cube. So this is the diagram here showing you, you've got your cross-sectional area of 2,000 square millimetres one side, 500 on the other, and it's telling you the HA equals 800 millimetres of water and HB is 200 millimetres of water. Where would you put your datum line? So you've got your point A and point B, where you're going to take them from. Don't forget, the datum line goes straight through the middle, and therefore the potential energy at point A and B is 0. So that's where you put your datum line in this particular diagram here. So what's the first we need to do now? We've done a sketch. Now we need to select the format of Bernoulli's that you're working in. And in this case, it's pressure energy is expressed in metres head. You know the millimetres head or metres head. So the formula you're going to use for metres head when it's talking about that is this one here of Bernoulli's. In this case, it's rho g ZA. So this is the metres head pressure at point A plus rho g HA plus half rho VA squared equals rho g ZB, which is the pressure energy at B in metres head, plus rho g HB plus half rho VB squared. So that's the formula we're going to use in this case. Straight away, cancel out potential energy giving you this. You can lose the potential energy. Next, you can insert any information you've got. Now, in this case, you can actually insert the pressure energy because it tells you the pressure energy in millimetre, 800 mil, which is 0.8 square metre. So you can substitute this in the formula. So straight away you get this. You've got 1,000 times 9.81 times 0.8, which is the pressure energy in metres head at point A, plus half rho VA squared equals 1,000 times 9.81 times 0.2, 200 mil on the manometer. That's that energy, plus half rho B squared. Multiplied out gives you 7848 plus half rho VA squared equals 1962 plus half rho VB squared. Now, transposition, take off the lower number, which is 1962. So if you take that off both sides, which is what you do, you get this. 5886 plus half rho VA squared equals half rho VB squared. So again, all you're trying to do is get the formula as small as possible. Now, the problem is here now, what do we need to determine? We need to determine the velocity of the water using Q equals VA. Now the problem you've got is we have two unknowns in the formula. We've got two unknowns. We do not know what Q is and we do not know what V is. We can work out the area. Now any time you get a problem with Bernoulli's, and this happens a lot, with two unknowns in a formula, you can't work it out with two unknowns. What you have to do is get a relationship between the two. In other words, how much bigger is that one than that one? Then all you do is you're going to substitute them in the formula. Do you understand? You have to get a relationship. How much bigger is one of those things than the other? And then you substitute it in. So how does this work? Then let's look at the formula. Well, the formula is Q equals VA. And we do know, therefore, VA AA equals VB AB. Now the area at point A is 4 times, as you can see on here, is 4 times the area at point B. The area at A is 4 times the area at point B. Well, therefore, if VAA equals VBAB, the velocity at point B must be 4 times the velocity at A. Do you understand? We know the area is 4 times bigger there than it is there. Well, therefore, the velocity there has got to be 4 times bigger there. In other words, VB equals 4VA. That's the relationship. VB equals 4VA. So what do you do in the formula now? Look at this formula here. 5886 plus half rho VA squared equals half rho VB squared. Now all you do is where it says VB, you substitute in 4VA. Because VB equals 4VA, all you do, instead of putting VA in the second part of the formula, VB, all you do is you put 4VA. Now that's 4 squared VA squared, you see, because it's in brackets. So you've got to multiply out the brackets now. And that gives you this. 5886 plus half rho VA squared equals half rho 16 VA squared. Do you understand? You've had to multiply out the brackets. So now we've got half rho VA squared on one side and 16 of these on the other side. What do you do to get rid of them on one side? Well, you take away half rho VA squared from both sides. Both sides. Transposing gives you this. 5886 equals half rho 15 VA squared. Now you've got one answer equals 5886. What you've got to do now is get rid of everything attached to the velocity. Everything. So, substituting the velocity gives you 1,000. Yeah, you got your 15, so multiply it out gives you 5886 equals 7,500 times VA squared. How do you get rid of the 7,500? Well, you divide both sides by 7,500. Gives you this. 0.7848 equals VA squared. We don't want to know VA squared. We want to know the velocity at A, not squared. Square root it. The opposite to a square is a square root. Square root both sides. The square root of 0.7848 equals 0.886. VA equals 0.886. Now you know the velocity at A, you can work out Q equals VA because now you've got your known. Q equals VA. A, the area at A is 2,000 square millimetres, which is, by transposition, if you work it out, that comes out at 0.002 metres squared. Because don't forget, you have to multiply it out to work it out. 2,000 square millimetres is 0.002 square metres. Therefore, Q equals VA. You know your V, which is 0.89, times that by 0.02 gives you 0.00178 metres per second. Q to the second. That comes out at approximately 1.78 litres a second. So that is the flow. 0.00178 metres cubed a second is 1.78 litres a second. That's how you work out these sort of problems. Don't forget, if you've got two unknowns, you need a relationship between the two. How much bigger is that one than that one? And then all you do is you substitute it in the brackets. But once you put it inside the brackets, when you multiply it out, you've got to multiply both of them out. So substitute it in the brackets. And that is how you work out these sort of problems. Now, that concludes this presentation on unravelling the mystery surrounding Bernoulli's theorem. What I want you to do is keep attempting all these questions involved in this presentation. And if you can do all these equations, all these questions in here, it's very unlikely you will not be able to solve a problem in any IFE examination, because they've got to be along these similar principles. It's got to come up in some sort of shape, form or one of these. So now, go through the questions yourself until you understand them again. And as soon as you're ready, then you're ready for the IFE examinations. Good luck.